For much of the 20th century, if a machinist said there was a sip in the shop, he was not just talking about a machine. He was telling you that his shop was playing a different game from the rest of the metalworking world. A higher game. A game where error was no longer discussed in thousandths or even 10,000ths, but in microns. A game where the operator was not merely a machinist, but something closer to a custodian standing at the final border between ideal geometry and real metal. Before coordinate measuring machines became common, before CNC took over the toolroom, before digital displays made precision seem like a matter of typing in the right numbers, there was a class of machine that could quiet an entire shop simply by running. Its name was SIP. Today, many people outside the trade can look at an old jig borer and fail to understand why it once cost such an astonishing amount of money. It is not massive like a heavy engine lathe. It does not overwhelm the eye like a modern 5-axis machining center. It does not look futuristic. There are no touch screens, no cable harnesses everywhere, no robotic tool changers. But in the first half and middle of the 20th century, if you needed to make a drill jig where every hole had to be positioned so accurately that future production parts would depend on it, if you needed to build molds, fixtures, templates, guide plates, metrology bodies, optical components, aerospace assemblies, or anything else where the relationship between holes mattered more than the holes themselves, then the machine that silenced competitors was often not a milling machine and not a drill press. It was a jig borer. And when the subject turned to jig borers, the name that inspired both respect and anxiety was SIP of Switzerland. So what exactly was SIP? How did one machine tool brand build an almost mythic reputation largely by putting holes in exactly the right place? And why, in an age defined by CMMs, CNC systems, and digital manufacturing, does the shadow of SIP still hang over the way toolmakers think about accuracy? The answer begins not in some giant American factory, but in a distinctly Swiss tradition, an obsession with measurement. To understand SIP, you have to understand the environment that produced it. Switzerland was not an industrial giant in the American sense, with endless steel cities, mile-long automotive lines, or wartime foundries devouring thousands of tons of iron every week. Swiss industrial strength grew out of something else entirely: watches, optics, precision instruments, scientific apparatus, and a manufacturing culture in which every thousandth of a millimeter was not a marketing slogan, but a condition of survival. In that world, precision was not simply the ability to cut correctly. It was the ability to measure correctly, transfer correctly, preserve correctly, and repeat correctly. A good machine did not just create a smooth surface. It had to preserve geometry. Out of that world came Société Genevoise d'Instruments de Physique, better known by its initials, SIP. The company was founded in Geneva in 1862 and was originally associated with the manufacture of scientific instruments and precision measuring equipment. That detail matters because SIP did not grow up with the logic of a mass-market machine tool builder. Its roots were in physical instruments, standards, metrology, and high-accuracy mechanisms. That shaped the company's DNA. To SIP, a machine tool was not first a device for removing metal. It was a machine for creating geometry. That is why SIP is remembered not as a builder of brute horsepower, but as a builder of coordinates. In precision machining, that difference is enormous. Plenty of machines can drill a round hole. Very few can guarantee that the hole is exactly where it must be, in perfect relation to every other hole, on a workpiece complex enough that the smallest positional error can ruin an entire jig, mold, or fixture. As modern industry expanded in the late 19th and early 20th centuries, especially in weapons, horology, engines, optics, and later aviation, that need became urgent. If you could produce a jig plate with absolutely reliable hole locations, you could use that jig to guide the manufacture of thousands of later components. In other words, the accuracy of one jig borer could propagate through an entire industrial system. That is where jig boring became its own art. And it is worth being precise here. A jig borer was not simply a very accurate drill. That description is so reductive it becomes misleading. A jig borer was fundamentally a machine designed to locate and create holes with extreme positional accuracy, while also allowing drilling, boring, reaming, and sometimes very light milling. But its center of gravity was always location and geometry. In the era before CNC, before digital error compensation, before electronic correction maps and automatic probing systems, the machine's accuracy had to exist inside the machine itself. The table, the lead screws, the slideways, the measuring system, the verniers, the thermal stability, the straightness of travel, all of it had to belong to the same almost obsessive level of finish and control. SIP entered that world and pushed the standard high enough to make many rival machines seem ordinary. They were not merely building equipment. They were building confidence. For decades, in countless tool rooms, if a drawing was too important to trust to an ordinary machine, it went on to the SIP. That reputation was not built through broad advertising. It was built through the judgment of skilled people. And once a reputation is earned in the tool room, it tends to outlast almost any marketing campaign. It is worth pausing here to understand what the tool room meant historically. A tool room was not a mass production floor. It was the place where the tools for production were made. Dies, molds, jigs, fixtures, punches, prototype parts, inspection tooling. It sat beneath the visible layer of industry. If the production line was where goods appeared, the tool room was where the very ability to make those goods was created. A mistake in the tool room did not merely ruin one part. It ruined the method for producing parts. That is why tool room culture was always different. It was less forgiving of error, more attentive to method, and far more likely to reserve respect only for machines that truly earned it. In that culture, SIP became a kind of symbol of authority. The early 20th century was the period when the mechanical world entered a ruthless race toward tighter and tighter tolerances. Watches, firearms, scientific apparatus, automobiles, aircraft engines, and military equipment all drove allowable error downward. If the second half of the 19th century was the era in which industry learned to repeat production, then the first half of the 20th century was the era in which it learned to repeat production at levels of exactness that began to seem irrational. Every advanced industrial system ran into the same question. How do you guarantee the relative positions of geometric features on a part? A piston can be turned round, but hole patterns, bearing locations, guide surfaces, center distances, axis relationships, those are what determine whether assemblies actually fit and function. Before CNC and CMMs, the answer did not come from software. It came from reference machines, highly trained operators, and sophisticated inspection practice. SIP succeeded because it understood that in this world, a machine had to be both a cutting tool and a measuring instrument. Many SIP machines were developed with extraordinarily refined coordinate reading systems, exceptionally smooth travel, and structures designed to minimize the effects of heat, vibration, and wear. The best SIP jig borers did not simply perform machining operations. They allowed the operator to establish an accurate coordinate system directly on the workpiece. That is where SIP's reputation began to move beyond excellent and into something more intimidating. An ordinary machine can let you believe you are working correctly until inspection proves otherwise. A truly great SIP was accurate enough to expose the weakness of everything around it: the operator's skill, the cutting tool, the thermal environment, the fixturing method, even the material itself. In a serious tool room, that was both a gift and a burden. If you had an SIP, you had far fewer places to hide. Between the World Wars, and especially after the Second World War, precision became a strategic asset. Aviation, optics, military hardware, precision engines, measuring instruments, stamping dies, mold making, and inspection fixtures all depended on the ability to produce trustworthy geometry. American, German, British, and Swiss builders each had their own traditions in precision machine tools. But SIP occupied a special position because it represented a school of thought many regarded as the absolute standard, even though its machine numbers were never as large as the output of more general-purpose builders. That led to another defining trait. SIP was always expensive. Not just expensive in purchase price, but expensive in the broader sense that the entire ecosystem around the machine had to rise to its level. To use an SIP properly, a shop needed better thermal stability, better trained workers, more rigorous inspection methods, and often a slower, more disciplined production rhythm. That gave the brand a very particular aura. Owning an SIP was not simply buying a machine. It was announcing that your shop was serious about accuracy at the highest level. One reason SIP entered legend is that it appeared at exactly the point where traditional mechanics met modern ultra-precision. Before the age of comprehensive digital measurement, industries like mold making and aerospace needed machines that could lock position into place by mechanical virtue alone. Plenty of fine milling machines could generate flat, beautiful surfaces, but producing a pattern of holes with such accuracy that a drill jig could later guide mass production without accumulated error, that was a different matter. The jig borer existed to solve that problem. SIP elevated it into something close to an art form. In classic mold shops, jig boring could feel almost ceremonial. Once the blank had been prepared, the reference surfaces established, and the calculations checked, the move to the jig borer was the stage where nobody wanted a mistake. That was when the most trusted man, or the man with the steadiest nerves, stepped forward. In many shops, only high-value workpieces, difficult replacements, or parts already carrying many hours of labor were permitted onto the SIP. The atmosphere around the machine was different, quieter, less rushed, far less forgiving. SIP became symbolic, not only because its machines were accurate, but because the company's philosophy seemed to reject the entire idea of good enough. What it pursued was the frontier where machine tools met metrology itself. That is one reason the name SIP appears not only in the context of machining, but also in the context of coordinate measurement and geometric inspection. Historically, that matters a great deal. The 20th century drive toward extreme accuracy was not led by a single trade. It emerged from the interaction of manufacturing, measurement science, optics, materials, and machine design. SIP was powerful because it stood at the intersection of all of them. As aviation accelerated, especially from the 1930s onward, The demand for positional precision became harsher. Aviation is a world where small geometric errors can cause assembly problems, vibration, misalignment, reduced lifespan, and, in the worst cases, systemic failure. As military aircraft and then jet aircraft appeared, manufacturing sophistication rose sharply. The fixtures, molds, gauges, and tooling for fuselages, wings, engines, hydraulic systems, and support equipment all required machines of extreme positional reliability. SIP, already trusted, became one of the names called upon in places where error was not allowed to spread. The same was true in mold making. Before EDM, high-speed CNC and CAM software changed the field, tool and mold work depended brutally on the ability to locate, bore, establish reference surfaces, and maintain perfect relationships among guide elements and mating components. A good mold is a closed geometric system. One wrong position can spoil the rest. SIP earned its reputation because it helped guarantee the most important geometric relationships in that system. To understand just how deep this obsession ran, imagine a world without touch probes scanning hundreds of points and calculating compensation on a screen. If you wanted to know whether you were right, you relied on standards, dial indicators, gauge blocks, measuring microscopes, templates, edge-finding methods, and above all, the inherent trustworthiness of the machine. In that world, a first-class jig borer was almost a working standard. Not an absolute laboratory standard, of course, but at the shop level, it was as close to truth as most people could physically touch. SIP built its business by selling that feeling. In the recollections of older generations of toolmakers, SIP is rarely remembered only in specifications. It is remembered in attitude. Operators talked about waiting for the machine to stabilize thermally. They talked about hand wheels with an almost unnatural smoothness. They talked about centering microscopes, about reading graduations with the concentration of ritual, about how a small, careless movement became more embarrassing on a SIP because the mistake was almost certainly human. That is what made the machine feel formidable. It did not forgive sloppiness. Another ingredient in the legend was relative rarity. Bridgeport became a generic word because there were so many of them. South Bend became beloved because it spread through schools, shops, and warships. Monarch 10EE became legendary because it combined precision, beauty, and symbolism. SIP occupied a different category. It was the kind of machine many shops could not afford, and many of the shops that could afford it still could not exploit its full capability. That gave its reputation the character of an elite order rather than a mass phenomenon. Many people knew SIP through stories from top tool rooms, or from photographs of machines kept so clean they looked almost sterile. That leads to a larger question. Why was jig boring once so important, only to be later overshadowed by CNC and CMMs? The answer lies in the structure of industrial development itself. The jig borer was created to solve one of the central problems of the pre-digital era: how to place holds and geometric features repeatedly, accurately, and verifiably. It was the coordinate machine of its age. But once numerical control, high accuracy scales, software interpolation, integrated probing, and coordinate measuring machines matured, many of the jig borer's unique functions were absorbed into a broader technological ecosystem. CNC machining centers could perform more complex work. CMMs could inspect faster and more deeply. EDM could create mold forms the jig borer never could. And so the jig borer's historic centrality declined. But decline in practical role is not the same as decline in prestige. In fact, when one supreme technology is displaced by another, it often loses market share while gaining symbolic power. SIP fell exactly into that condition. Once CNC and CMMs took command, machinists began looking back at the SIP jig borer as a reminder of an age when extreme precision had to be achieved through cast iron, steel, discipline, graduations, and thermal control. There was no miraculous algorithm standing between the operator and the work. There was only the machine and the human being. That is why the myth of SIP did not die with the decline of traditional jig boring. It was preserved as proof that analog mechanics had once reached levels of precision that still feel almost impossible. In that sense, SIP stands for something broader than a product line. It represents the upper limit of the toolmaker's craft before the digital age. Culturally, that matters. Every era has machines that symbolize the highest level of manufacturing thought. In the late 19th and early 20th centuries, that might have been the standard lathe, the cylindrical grinder, or the ultra-precision measuring instrument. In the middle of the 20th century, inside the world of the toolroom, SIP was one of those monuments. It reminded people that once, to achieve the highest standards, an entire shop had to build a culture around the machine. And if you look closely at the technical essence of the legend, it was never just about tight tolerances. Tight tolerances alone do not create mythology. What made SIP revered was its ability to deliver positional accuracy systematically. In real manufacturing, a beautifully sized hole in the wrong place is still wrong. A polished surface that has lost its geometric relationship to the datum is still a failure. SIP became invaluable because it solved the problem of relationship. That is what distinguished the jig borer from many other machines that were judged primarily by horsepower or surface finish. Put another way, SIP helped industry control space. And the control of three-dimensional space is the invisible foundation of modern manufacturing. From stamping dies and drill jigs to hydraulic valve bodies, aircraft assemblies, and optical devices, everything depends on relative position. Before the CMM, the thing that often allowed a shop to create and verify that spatial truth was a machine like a SIP. It is not accidental that SIP later became associated directly with coordinate measurement itself. This is where the story broadens from a jig borer builder into a metrology symbol. In manufacturing history, production and measurement are always chasing each other. As machines become more accurate, measurement must become more refined. As measurement becomes more refined, machines are forced toward even higher precision. SIP stood at the center of that cycle. That is why it sold more than machinery. It sold a way of thinking about standards. In the post-war years, especially as Western industry moved deeper into jet aviation, space-age engineering, complex molds, and mass precision production, the status of companies like SIP reached its peak. A SIP jig borer in the toolroom was both a production asset and a prestige asset. It told customers, partners, and the shop's own workforce that this was a place capable of taking work others would hesitate to accept. The machine did not create skill by itself, but it unlocked rare categories of skill. It should also be said plainly that legend has a way of smoothing over harsh reality. ASIP did not transform an average shop into a world-class one merely by existing. Quite the opposite. Many ultra-precision machines were wasted in environments that lacked the culture to support them. To truly exploit ASIP, a shop needed strong measurement practice, inspection discipline, tool grinding capability, fixturing skill, temperature control, and above all, the right people. So the old remark that everyone feared the SIP was never just fear of the machine. It was fear of the standard that came with it. That is also why veteran machinists often speak of SIP in a tone that is half admiration and half challenge. Some machines are good enough to make people comfortable. Some are so good they make people feel they must become worthy of them. SIP belonged to the second category. That is a rare position for any machine to hold. As CNC became stronger in the second half of the 20th century, many people began saying that the jig borer would soon be nothing more than history. In terms of mass production, that was largely true. A good CNC machining center, equipped with scales, ball screws, compensation, and probing, could perform work that once required multiple machines, multiple setups, and multiple stages. But those claims often missed something important. CNC did not erase industrial memory. The people who had lived through the age of SIP knew there was a deep difference between precision achieved through digital models and precision built into the mechanical structure of the machine itself. Both matter, but they create different professional cultures. SIP belongs to the culture in which the operator had to feel the machine, understand the machine, and make geometry with the machine. The digital age moved some of that responsibility into software, control systems, and programming methods. That does not make the earlier era inferior. It simply makes it harder to reproduce. And that is why the story of SIP survives today as a reminder of how far analog mechanics once reached. In modern mold shops, very few places still use a jig borer as the unquestioned center of the tool room. EDM, high-speed CNC, coordinate grinding, 3D scanning, and CMMs have transformed the entire technological chain. But in traditional shops, in restoration work, in advanced training, and in the shared memory of the trade, SIP remains a psychological benchmark. It is the name people reach for when they want to describe accuracy so extreme it almost stops making economic sense, yet remains entirely sensible as a matter of craft and honor. Another reason the SIP story remains compelling is the contrast between its appearance and its role. Set beside warships, submarines, jet engines, or giant transfer presses, a jig borer can seem modest. And yet it was often one of the machines standing behind those larger systems. That pattern repeats throughout industrial history. The most important tools are often not the biggest ones. They are the ones that create the possibility for bigger things to exist. SIP belongs to that class. It was part of the invisible infrastructure of precision. At a wider level, the story of SIP also reflects a larger shift in 20th century industrial power. There was a time when competitive advantage came from building the most accurate machine in the world. Later, that advantage shifted toward integrating numerical control, electronics, automation, software, service networks, and global supply chains. In that new order, many classic mechanical legends lost market position without losing technical prestige. SIP is one of the clearest examples. It is remembered as a historical standard even after the economic logic of the machine tool market moved elsewhere. And that is what gives the name its enduring hold. SIP represents a summit no longer at the center of production, yet still at the center of professional imagination. Every trade has symbols like that. For the precision tool room, SIP is one of them. Not because everyone used one, but because everyone understood what it meant. If you had to reduce SIP's legacy to a single idea, it might be this. The company turned the simple act of placing a hole in exactly the right position into a standard of industrial honor. That sounds small to anyone outside the trade, but people inside the trade understand that the ability of machines to assemble, align, guide, mesh, repeat, and move correctly all begins with points that are in the right place. A hole in the right place is the foundation of a system in the right place. And before computers helped hold every error in check, SIP was one of the greatest masters of that art. Looking back from the present, the appeal of SIP is not only about company history or technical specifications. It lies in the question the machine still asks every later generation of machinists. What is precision really? Is it a number on an inspection report? Is it repeatability at scale? Is it software compensation? Or is it a philosophy of building machines and building people, disciplined enough to turn metal into trustworthy geometry? SIP seems to answer that it must be all of those things. But first, it is an attitude, the refusal to accept approximation when the work demands absolutes. In the finest tool rooms of the 20th century, the SIP stood as a quiet reminder that there are standards you cannot reach in a hurry. To approach them, you have to slow down, measure more carefully, think further ahead, and work as if every micron has its own moral weight. That is why SIP was never just a jig borer maker. It was a mechanical philosophy cast in iron and steel. Even now, a well-preserved SIP often stirs more emotion in experienced machinists than a brand-new machining center. Not because it is more powerful or more flexible, but because it represents a time when ultimate accuracy was pursued through almost pure mechanics. A time when if you wanted micron-level truth, you could not hide behind an interface. You had to understand thermal distortion, backlash, contact, datums, and reading systems down to the bone. That is why tool rooms feared the SIP. Not because it was loud, not because it was physically imposing, not because it was brutal. They feared it in the way people fear an absolute measuring stick. Once that standard is present in the room, all carelessness becomes visible. Every excuse weakens. Every error becomes personal. The race toward absolute accuracy before CMMs and CNCs produced many legends. But few names kept their aura as purely as SIP. In the history of molds, aerospace, fixtures, and ultra-precision mechanics, it was never the biggest company and never the loudest. It was the company that made even highly skilled people admit there was still another rung above them. In industry, that is a rare form of power. And in the end, that may be SIP's greatest legacy. It forced an entire trade to redefine the meaning of precision. Before SIP, precision could still be a goal. After SIP, for many tool makers, it became something closer to an oath. The company built a standard under whose shadow later generations still work. If you enjoyed this video, like, subscribe to the Gear Archive, and leave a comment with your thoughts. Thanks for watching, and I'll see you in the next one.